we're going to start discussing the pH scale for acids and bases. What pH is saying is that it's taking the concentration of H+, which, remember, the definition of acid is to donate hydrogen. So we're taking the concentration of that donated hydrogen, and we are taking the log of it. And what happens is that you get this nice number that's really easy to communicate with one another. Sometimes it gets cumbersome to talk about the actual concentration, but when you have a number that you can relate other acids to, it makes a little bit more sense. Notice it's pH, and we're taking the log of H. That's actually really important. We need to make sure that this is always the concentration of either H3O+ or H+. If you're given the concentration of OH-, we're going to have to do some mathematics to change that. Now, the air that we breathe, the water that rains down, we have carbon dioxide that we exhale. It mixes in with the water naturally. This happens all the time to make carbonic acid. Water naturally has a pH of 5.6. That's making it acidic. The pH scale ranges from 0 to 14. Water is 7, which is neutral. Anything below water is acid. Anything above that is base. So from 0 to 7, it's going to be an acid. And from 7 to 14, it's going to be a base. So if we look at the pH scale, here's some generalities. It indicates how acidic a solution is. It ranges from 0 to 14. And this is what I was just saying, that 7 is the neutral, below it is an acid, above it is a base. That's really important to remember. So you want to memorize that. So let's just take some general background. For instance, cola with a carbonated beverage, because it has carbonic acid, is 3.0 because of the carbon dioxide in there. The stomach acid is 1.6. Once again, very acidic. Here's our pure water, but here's salt water. That's seawater. So it becomes more basic. Milk and magnesia, antacids are more basic. So let's see if we can look at determining if something is an acid, base, or neutral. Well, pH of 1.5. From 0 to 7 is an acid. From 7 to 14 is a base. So 1.5 would then be an acid. This time they gave you the concentration. They didn't actually give you the pH, but we can figure out what the pH is by going pH is equal to negative log of H3O+. So that means pH is equal to the negative log of 1 times 10 to the negative 8. So to put this into your calculator, you're going to have to find the log button. You're going to push the log button, and then you're going to type this in, 1 EE negative 8, or 1 EXP negative 8. That comes out to be negative 8, which cancels out to be a positive 8. So when we're looking at the scale, between 7 and 14 is a base. Okay, Sprite is a 3.0. That puts it in the acid range. pH of 7, that is water. That's going to be neutral. 3 times 10 to the negative 10, but that gives us OH. This equation, you have to have H3O plus. Notice the difference. That's a very, very, very important difference. So we had to figure out the concentration of H3O before we figure out the pH. So we're going to use that equation before of 1 times 10 to the negative 14 is equal to H3O plus times OH minus, which is 3 times 10 to the negative 10. So H3O plus is then going to equal 1 times 10 to the negative 14 over 3 times 10 to the negative 10. That comes out to be 3.3 times 10 times 10 to the negative 5. That is the number we are then going to put into the pH equation. So pH is equal to negative log 3.3 times 10 to the negative 5. Negative 4.5 is the answer. So pH is equal to 4.5. That is in the acid range. So notice how we have to combine steps in order to figure out the answer sometimes. That's why the previous equation of 1 times 10 to the negative 14 is so valid. It's so valuable. And then finally we have H3O plus. They give you that concentration, so we can put that right into the equation. pH is equal to negative log 5 times 10 to the negative 12. So you're going to put 5, second function EE, negative 12, into your calculator. That comes out to be negative 11.3, which is 11.3, which is then in the basic range. Sometimes it can get kind of complicated, but notice it's the same steps every single time. And those are answers again. So we know from our previous slides that rain typically has an acidity of about 5.5. However, if it drops far below 4.5 to 5, it starts having issues with the plant life, killing the plant life. It starts to tear apart different parts of the plant, like the leaves and whatnot. It interferes with photosynthesis. It just creates all kinds of issues. So let's practice some more of determining the pH. So pH is equal to negative log of 1.0 times 10 to the negative 3. That means we're going to put log 1.0 EE or EXP negative 3. So that means pH is going to come out to be positive 3, which means it's acidic. Let's try another one. I'm going to give you a minute to practice this one on your own. You know you're going to need the equation pH is equal to negative log of H3O plus. We're going to put this number into that concentration. When you put log of 1 times 10 to the negative 5 into the calculation, it should come out to be negative 5. which is then going to equal 5.0. Alright, we're going to do another one. We're going to use the exact same equation we have been. Notice they give you the H3O plus concentration, which then gets put into the equation. The log of that number comes out to be negative 3.7. We're going to take the negative of that, which comes out to be positive 3.7. Let's take a look at this for a second. As far as concentrations of the OH and the H3O plus is considered. Here's our scale. Here's neutral. At 7, the OH and the H3O plus is exactly the same. This is talking about 1 times 10 to the negative 7, 1 times 10 to the negative 7. They're both the same. However, when you get to a more acidic solution, for instance, pH of 1, it's 1 times 10 to the negative 1, 1 times 10 to the negative 13. Notice as the H3O plus went up, the OH minus went down. If we reverse that process, if it's a basic solution, the OH minus concentration went up 1 times 10 to the negative 2. That means 0.01 molar. Whereas the acidic concentration, the hydrogen concentration is 1 times 10 to the negative 12. That's 0.000. Notice that the OH minus is a really big number. The H3O plus is a really small number. That's the differences between the hydrogen and the OH group concentrations and how it relates to the pH. Notice when it's relating to pH, it's always referring to the H3O plus concentration. So for instance, negative 4, pH of 4, times 10 to the negative 9 is about a 9. It's always referring to the H3O plus. Don't get caught in the trap of figuring out the concentration of OH minus and using that for the pH. So what's the H3O plus concentration when we're given the pH of 10? We can actually reverse the process. pH is equal to the negative log of the H3O plus concentration. Now we're looking for this. That is what we're looking for, the H3O plus concentration. We know the concentration, the pH is 10. So 10.0 is equal to negative log of H3O plus. So we're going to get rid of this negative sign first. Now we're really looking for this, but we have it as log of that. In order to get rid of this log, if you look on your calculator, chances are where you see the log button, you're going to see something that says like 10 to the x. That's called the inverse log. So we're going to take 10 to the x of both of these. The 10 to the x and the log cancel out. So that gives us just H3O plus on the right hand side. And when you put 10 to the x of negative 10 into your calculator, you're going to come up with 1 times 10 to the negative 10. And here's our answer right here, C. The takeaway lesson to this is to get to the concentration, you're going to put the negative pH, put 10 to the x of the negative pH. This canceling out is important mathematically, but as long as you remember to do the inverse log of the pH, you should be fine. Okay, so now we're looking for the OH minus concentration. They're giving us the pH. Remember, the equation for pH is negative log of the H3O plus concentration. So that means when we take the inverse log, we're getting the H3O plus. We're not getting the OH, but we can with one more step. So 2.00 is equal to negative log H3O plus. First thing you want to do is get rid of this negative sign. So negative 2.00 is equal to log. To get rid of this log, we're going to take 10 to the x of this and 10 to the x of this. The log and the 10 to the x cancel out to leave H3O plus on the right hand side. So we're going to put the 10 to the x button. It's probably the same one as the log button, but it's probably the second function. So 10 to the x of negative 2. That comes out to be 0.01 more. That's the concentration of H3O plus, though. We're looking for OH minus. So 1 times 10 to the negative 14 is equal to H3O plus times OH minus. We're going to put this 0.01 into the H3O plus. So 1 times 10 to the negative 14, 0.01 OH minus. So we're going to divide 1 times 10 to the negative 14 divided by 0.01. These cancel. That leaves us with OH minus is equal to 1 times 10 to the negative 12. And that is how you do pH. Remember, it's always the negative log of the H, not the OH, the H. And always remember that you can connect the pH equation with the 1 times 10 to the negative 14 equation.